What is a bond enthalpy?
Bond enthalpy refers to the amount of energy it takes to break a chemical bond. This tells us how favorable a chemical bond is relative to the separation of the two fragments on either side of the bond.
How can I grow crystals of rock candy?
Chemistry principles encountered in this experiment: crystallization and recrystallization. Solubility materials you'll need: sugar, 3 cups, water, glass jar, a pencil string, cotton. 15 centimeters will do. Pan, for boiling water, microwave or stovetop, optional. Food coloring, optional. Flavoring extracts. The procedure: begin by stirring 3 cups of sugar and 1 cup of water into a pan. While stirring frequently, heat the mixture to a gentle boil. The goal is to just barely get the mixture to its boiling point. And then stop the heating. We don't want to evaporate off too much of the water. Then remove the solution from the heat source. If you want to add food coloring or flavoring, now is a good time to do so. Either way, the candy is made of sugar, so it will still taste fine. Cool the pot containing the solution in the refrigerator until it's just below room temperature. In the meantime, tie the cotton string to the pencil, and place the pencil atop the jar, allowing the string to dangle down without touching the bottom. You may need to trim the string such that it doesn't touch the bottom of the jar. You may wish to tie a lifesaver candy or other weight to the end of your string to hold it taut. Wet the string and dip it in a little bit of crystalline sugar. Not the sugar you just mixed with water and heated. These sugar crystals will serve as the nucleating sites on which the rock candy from your sugar solution will crystallize. Pour the cool sugar solution into the jar, and hang the pencil and string into the solution. Cover the jar with aluminum foil, a paper towel, or anything else, such that it will not be disturbed. The crystals will take several days, or possibly as long as a week, to grow. Sugar from the solution will continue to crystallize onto the growing crystals on the string. You can check on the crystals occasionally, but you should not bump, tilt, turn, shake, or move the jar, if possible. The crystals will grow larger if you leave them undisturbed. Once they are done growing, remove your string, and your rock candy is ready to eat.
What is an alloy?
A mixture of metals, e.g., bronze, a mixture of zinc and copper.
What is specific heat?
The quantity of heat energy needed to increase the temperature of a substance by a fixed amount.
What is a substitution reaction?
The exchange of one functional group, or atom, for another is called a substitution reaction. The transesterification reaction above is an example of substituting AOC2CH3 group for AOC3 group.
What is the half-life of a radioactive species?
The half-life of a radioactive species is the amount of time it takes the quantity of the species to decrease by half. After one half-life, one half of the initial quantity of material will remain. After 2 1/4 will remain, after 3 1/8 will remain, and so on. Half-lives of radioactive nuclei vary widely, and we'll list just a few values below to give an idea of the range of timescales covered.
Why did Frederick Sanger, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the structure of proteins, especially that of insulin. Sanger established the structure of insulin by first recognizing that it was made up of 2 chains of amino acids, one 31 and the other 20 residues long. He proceeded to establish the sequence of amino acids, all 51, in the 2 chains, thus determining the chemical composition of insulin. Insulin is a key peptide hormone that regulates glucose levels in the human body. In addition to characterizing the structure of this important hormone, Sanger in fact did much more. The methodology he applied to characterizing its structure went on to be used by numerous other scientists in many other situations to characterize protein structures.
What is the Hess's law?
States that the change in enthalpy for a reaction that occurs in multiple steps is equal to the sum of the change in enthalpy for each step, related to the first law of thermodynamics.
What is a phase?
A state of matter, e.g., solid, liquid, or gas.
Why do organometallic complexes make good catalysts?
Catalysts, by definition, provide a lower energy route to the product. Organometallic complexes react with organic molecules in ways that are very different than how organic molecules react with themselves. At the most basic level, this is because transition metals have d orbitals that are involved in making and breaking chemical bonds. with additional orbitals that are of different symmetry than the sand p orbitals that are available to elements like carbon, nitrogen, and oxygen. Organometallic complexes can accomplish feats that are just impossible, forbidden, for other elements.
What is the ideal gas law?
An equation that approximates the properties of gases, commonly written as PV equals nRT, where P equals pressure, V equals volume, N equals number of moles, R equals gas constant, T equals temperature.
What are the main classes of biomolecules?
The four main classes of biomolecules are proteins, carbohydrates, lipids, and nucleic acids. Proteins are some of the most diverse biomolecules, and they can perform functions such as protecting the body from pathogens or acting as catalysts for chemical reactions. Carbohydrates can be a source of energy when your body needs it. Lipids include fat molecules and are used for energy storage, as well as to form the membranes that surround each cell. Nucleic acids are what make up our genetic material and store the information that determines a lot about who we are. We'll go into more details about each of these types of biomolecules in the upcoming pages.
What is the Sun made of?
The Sun is made up of extremely hot gaseous elements, primarily hydrogen and helium. There are also small amounts of oxygen, nitrogen, carbon, neon, iron, silicon, and magnesium. Because it is so heavy, the Sun produces an extremely strong gravitational pull, which leads to very high pressures and temperatures, especially near the Sun's core. Roughly 27 million degrees Fahrenheit, or 15 million degrees Celsius. These extreme conditions can cause two hydrogen atoms to undergo fusion. See nuclear chemistry, to create a helium atom. The other two parts of the Sun are the radiative layer, the middle layer, and the convective layer, the outermost layer. Below is a table listing the relative abundance of elements in the Sun. In total there are at least 67 elements that have been identified as being present in the Sun. This table lists the 10 most abundant ones.
What is a stereochemistry?
Relative arrangement of atoms of a molecule in 3D space, see also stereoisomer, enantiomer, diastereomer.
What is the hottest planet in our solar system, and why is it so hot?
Venus is the hottest planet. With an average surface temperature of 900 degrees Fahrenheit or 481 degrees Celsius. It's the second closest to the Sun, with only Mercury orbiting closer. Interestingly enough, the high temperatures on Venus are largely due to a greenhouse effect due to the very high levels of carbon dioxide, CO2, in its atmosphere.
What makes hot peppers so spicy?
The molecule that makes hot peppers so spicy is called capsaicin, see its chemical structure below. This molecule behaves as an irritant to humans and other mammals. But some of us still really like its flavor.
Does putting urine on a jellyfish sting really help?
You may have heard of this before, but it seems that it may just be an old wives' tale. Washing the area of the sting with salt water is recommended so as to deactivate any of the stinging cells from the jellyfish that may be present on your own skin. Fresh water may actually reactivate the cells that caused the sting, causing you further pain.
What is a reversible reaction?
A reaction where the products can be converted back into the reactants.
How did chemistry affect trade in ancient times?
Ancient chemistry was involved in the production of many goods that were important to trade. These included salt, silk, linen dyes, precious metals, wine, and pottery.
What is a biochemical pathway?
A biochemical pathway is a cycle of chemical processes that mutually interact to effect some purpose important for biological function.
What is silicone? Is that the same as silicon?
Silicon is an element, while silicone is a polymer with a backbone of silicon and oxygen atoms. These polymers are very resistant to heat and have a rubbery feel. The latest squishy cookware and bakeware is made out of silicone.
What is the Le Chatelier's principle?
States that any change, concentration, pressure, temperature, volume to a chemical system at equilibrium will cause the equilibrium to shift in order to counteract that change.
How is nuclear chemistry related to the alchemist's goal of transmutation?
Alchemists sought a way to turn common metals into gold, which we now know is not possible to do in any simple way. The reason is that transmutation would involve converting one element into another, which can't be done by simple chemical processes. It would require a nuclear reaction to take place. Either a heavy nucleus would have to divide into a gold nucleus and another byproduct, or two lighter nuclei would have to combine to form one of gold. Neither of these things happen readily. If early alchemists had recognized the distinction between more ordinary chemical reactions and the nuclear reaction they were looking for, it would likely have saved a lot of time and effort.
Does hairspray contain polymers?
Yep, and almost the same ones that make white glue and acrylic paints. Many hairsprays contain vinyl acetate, or something similar. Polyvinyl pyrrolidone and or lots of other variants. Like glue, you also need a liquid to disperse or dissolve the polymers. But in hairspray a mixture of alcohol and water is normally used.
What is an evaporation?
Conversion of a liquid into a gas.
Who built the first MRI machine?
Dr. Raymond Damadian, who was formerly trained as a medical doctor, led construction of the first MRI. The first MRI capable of imaging a human was completed in 1977.
When did the theory of the atom come about?
The idea of the atom was originally proposed by ancient scholars. The philosophers Democritus and Leucippus are often credited with proposing the early notions of the atom, including the ideas that many different kinds of atoms exist, that there is a substantial amount of empty space between atoms, and that their properties are responsible for the properties of materials we see and interact with. For centuries, ideas about the structure and properties of the atom were based largely on conjecture and logical arguments. And it wasn't until the 1800s that experiments began to allow atomic theory to advance to where it is today.
How many elements are there, and will more be discovered?
As of the writing of this book, 118 elements have been discovered. The lightest element, with only one proton and an atomic mass of 1.00794 g/mol, is hydrogen. The heaviest is ununoctium with 118 protons and an atomic mass of 294 for the only detected isotope. Considering that 5 new elements have been discovered since the year 2000, it seems very likely that more elements will be discovered. It is getting harder and harder for scientists to discover, or synthetically create, new elements, though, because the heaviest elements that have been observed to date are usually unstable and decay extremely quickly.
Why do hard-boiled eggs spin, while raw eggs don't?
Hard-boiled eggs are solid all the way through, so when you spin the egg, all the energy you apply goes into spinning the whole object. Raw eggs have yolks that are free to move about the interior of the egg, however. So when you spin a raw egg, the yolk moves to the outer edge of the inside of the egg, which consumes some of the energy you applied. The other difference you can see is what happens after you stop these two eggs from spinning. Stopping the hard-boiling egg stops the entire system. Because the yolk is trapped in the solid, cooked egg white. Inside the raw egg, however, even after you stop it, the yolk is still spinning around. So if you take your finger off of a raw egg that was just spinning, it can start moving again, seemingly on its own.
What is the ozone layer and why is it so important?
Ozone has the chemical formula O3, and it is a gas that is naturally present in the Earth's atmosphere. Most of the ozone in the atmosphere exists as part of a layer that sits a few miles above the ground. This is the ozone layer, and it serves to protect the Earth from a significant fraction of the potentially harmful UV light from the sun. Depletion of the ozone layer means that more harmful UV light reaches the Earth's surface. Ozone is also a greenhouse gas, which means that it also plays an important role in controlling the Earth's climate.
When was nylon discovered?
Nylon 66 was first made by Wallace Carothers, a scientist working at DuPont, R., on February 28, 1935. Dr. Carothers also contributed to the discovery of neoprene, which is used to make suits used for scuba diving.
What about the occipital lobe?
The occipital lobe is in charge of visual perception. It's responsible for processing the information received by our eyes.
Why did Otto Wallach, Germany, win the Nobel Prize for Chemistry?
For his services to organic chemistry and the chemical industry. By his pioneer work in the field of alicyclic compounds. Alicyclic compounds are aliphatic, meaning they have no aromatic rings. And cyclic, meaning they do have other rings. Cyclohexane is a simple example of an alicyclic compound. Wallach specifically studied terpenes, which are found in the essential oils of various plants. He was able through chemical transformation to make these liquid molecules into crystalline solids, which made them easier to study with the methods available at the time. Wallach is also known for a number of different organic reactions that all still bear his name today. Wallach rearrangement, Wallach's rule, Wallach degradation, Lückert-Wallach reaction.
What is a fatty acid, and what is the difference between saturated and unsaturated fats?
Fatty acids are long, organic molecules that contain a carboxylic acid functional group at one end. See the picture below, and a long, nonpolar tail at the other end. They are an important source of energy in the body because they can be metabolized to generate ATP, which the body uses as fuel. When you're looking at the nutrition information on your food, the concept of saturated versus unsaturated fats can be understood by looking at the structure of a fatty acid. Saturated fats are those that contain only single bonds connecting each carbon atom in the chain. Recall that double and triple bonds are called units of unsaturation. Unsaturated fats are any fats that do have units of unsaturation, or, in other words, that do have double bonds between some of the carbons in the chain. All fats are either saturated, top illustration, or unsaturated, bottom illustration.
What is a valence electron?
An electron in the valence shell of an atom.
What is a mole?
The SI unit used to describe the amounts of chemical, 6.023 x 1023.
What is a thermoset?
Unlike a thermoplastic, thermoset materials are cured such that they don't soften when exposed to heat. At least up to a certain point. This curing step usually introduces a lot of cross-links between polymer chains, which creates a rigid network. These materials are much more difficult to recycle, but are used where high temperature stability is needed.
How was oxygen gas first discovered?
Well, to answer that question, you would first want to know who first discovered oxygen. And there is no simple answer to that question. There are three people to whom discovery of this can be ascribed: Carl Wilhelm Scheele, Joseph Priestley, and Antoine Lavoisier. Scheele produced O2, he called it fire-air, from mercuric oxide, HgO. In 1772, but the result wasn't published until 1777. Meanwhile, in 1774 Priestley produced O2, he called it dephlogisticated air. Using a similar experiment, which was published in 1775. Lavoisier claimed to have independently discovered the gas, and was in fact the first to explain how combustion worked via quantitative experiments, leading to the principle of conservation of mass, and ultimately disproving the entire idea of phlogiston. WIO. So Scheele found it first, but didn't report it. Priestley reported it first, but didn't have the explanation correct, and Lavoisier was last, but nailed it. Who would you give credit to?
What happens in the cerebellum?
The cerebellum is important for controlling your sense of balance, motion, and your motor skills in general.
Does eating chocolate or fried food cause acne?
No. Acne is caused by oil glands in a person's skin overproducing an oil called sebum, which is what the body naturally uses to keep skin lubricated. If this excess oil, along with dead skin cells, blocks your pores, then your skin can become irritated and a pimple may form. While the causes of excess sebum production are not definitively established, there is no reason to think that chocolate or fried foods are at fault.
What is a monomer?
If polymer means many parts, a monomer is one part of that whole. A monomer is a molecule that is attached to many copies of itself to make a polymer molecule. Usually these bonds are covalent, but not always.
What is diffraction?
Change in the direction of a wave caused by an obstacle, be it a wall, or a nucleus.
What determines the most favorable packing arrangement?
Thermodynamics. Okay, that's a cop-out answer. Attractive interactions, like van der Waals forces or hydrogen bonding. can play a large role in determining the stability of a crystal lattice. The most stable packing arrangement can also depend on the pressure and temperature at which the crystal forms.
How is X-ray diffraction used by chemists?
Chemists use X-ray crystallography to determine the exact structure of chemical compounds. This involves taking a solid crystal of a pure compound and diffracting X-rays off of it, which produces a complex diffraction pattern. Using computer software, the diffraction pattern can be processed to yield a structure that describes the structure of an individual molecule of the compound making up the crystal. This is a powerful technique, but it can only be used on compounds that can be crystallized. It's also worth pointing out that the solid phase structure of a molecule is not always the same as that in a solution. So caution should be used when relating crystal structures to chemical reactivity in the solution phase.
What is a kilogram?
Standard base unit of mass.
So how then do astrochemists detect H2 in space?
By looking at other parts of the electromagnetic spectrum. Chemists can detect molecules with no net dipole like H2, detected by UV radiation, or CH4, detected by IR.
Why does my chocolate turn white when I wait too long to eat it?
Chocolatiers refer to this as a bloomed chocolate, which is a wonderfully obscure and appealing way of describing the white stuff that forms on old Halloween candy. There are two processes that could be happening here, either sugar bloom or fat bloom. Sugar bloom is the candy world's way of saying sugar crystallization. If your candy is exposed to moisture, sugar molecules dissolve out of the fat in the chocolate, and once that moisture evaporates, the separated sugars have a chance to crystallize. If your candy has stayed dry but underwent a quick temperature change or was stored warm, it's probably fat from the cocoa butter that has separated from the chocolate. In either case, it is usually still fine to eat.
What is the Henderson-Hasselbalch equation?
Equation for pH of a solution as a function of acid strength, pKa, pH equals pKa plus log 10, A-/Ha.
What are comets made of?
Comets are space snowballs with some dirt sprinkled in. No, really. Comets are typically balls of rock, frozen water, and gases. Sometimes other chemicals are present in much smaller amounts. These include methanol and ethanol, hydrocarbons, and in 2009 NASA's Stardust mission confirmed that glycine, an amino acid, was present in the comet called Wild 2.
What makes metals feel colder than air to the touch?
Metals feel colder than air when you touch them because they are good conductors of heat. The cold metal is able to conduct heat away from your hand through the entire object quickly, making it feel colder than the air around you.
How much energy in the United States comes from hydroelectric power sources?
About 10% of the electricity in the United States comes from hydroelectric power sources. The state of Washington leads the United States in hydroelectric energy production, with roughly 87% of the state's electricity coming from hydroelectric power.
What is a hybrid orbital?
An orbital that is composed of multiple atomic orbitals, e.g., sp3 hybrid orbital.
What is the mobile phase in chromatography?
The mobile phase is the vaporized sample in gas chromatography or the solvent used to elute the sample over the stationary phase in liquid chromatography.
What is a carbon ligand?
A carbene is a molecule that contains a carbon atom with 2 bonds and 2 unpaired valence electrons. This leaves the carbon atom neutral in terms of formal charge, see atoms and molecules, but still typically much more reactive than a typical carbon atom with 4 bonds. Carbenes are often found coordinated to metal centers in organometallic complexes. These carbene ligands are less reactive than a free carbene species. And actually you might be surprised to learn that organometallic carbene complexes aren't always prepared from the reactions of free carbenes with metal centers. As an organometallic ligand, a carbene may be either electrophilic or nucleophilic at the carbon atom. See organic chemistry. Carbene ligands that are electrophilic at carbon are termed Fischer carbenes, and those that are nucleophilic at carbon are called Schrock carbenes. A third class of particularly unreactive carbene ligands are termed persistent, or Arduengo, carbenes.
What is a calorimeter?
A tool used to measure the heat change associated with a chemical reaction.
What is cracking?
Fluid catalytic cracking is the name for the process that converts high-boiling hydrocarbons found in crude oil into lighter hydrocarbons that are more useful as gasoline and other products. These units operate continuously for years at a time, and there are hundreds of them around the world. In addition to the high temperature and heat that these reactors use to break down long hydrocarbons, there are catalysts used to help speed up the process. These catalysts are usually strong acids in the form of zeolites. Specifically fugazit, which is a mixture of silica and alumina.
What is dextrorotatory?
Having the property of rotating plane polarized light clockwise.
Does all the alcohol really boil off when I cook with wine?
Not really, no. It's common lore that when you add red wine to pasta sauce that the alcohol evaporates rather quickly. This idea is supported by the fact that alcohol has a lower boiling point than water, so it should evaporate quickly. People who actually studied this, however, have shown that even after an hour, 25% of the alcohol you added is still in the sauce. If you want a truly non-alcoholic marinara, you need to simmer for at least 2.5 hours.
What is a reaction?
The process of changing chemical bonds in a molecular or ionic compound.
Why did Fritz Pregel, Austria, win the Nobel Prize for Chemistry?
For his invention of the method of microanalysis of organic substances. Pregel, a chemist and physician, was awarded the prize for his work on ways to quantitatively characterize organic molecules. In particular, he made great improvements to elemental analysis, which reveals the amount of various elements in a substance by measuring the combustion products. Or, more simply, burn the stuff and see how much CO2, H2O, and NO are released.
Are green, oolong, and black teas made from different plants?
No, all tea is made from the leaves of a single plant, Camellia sinensis. That statement excludes herbal teas, though, which are more accurately called infusions. Different categories of tea are prepared using different processes of wilting, bruising, and drying the leaves. Green tea is processed within a day or two of harvest, which preserves the natural chemicals of the fresh leaves. Black tea leaves are prepared by an oxidation process at high temperature and humidity, and then dried. Oolong tea is in between green and black, the leaves are left for a few days to wither, after which a short oxidation process is performed.
What is a monomer?
A group of atoms that forms the repeating unit in a polymer.
What is a valence band?
Highest energy range in which electrons are normally present at 0 K.
What are a few of the big challenges materials science researchers are working on now?
One challenge is to make materials that will allow us to start making smaller, lighter cars that can more easily be powered by electricity. LED lights are another big area in materials science right now. We need to develop materials that can use energy efficient LEDs to produce the kinds of light we need at low costs. One last area to mention is reducing the amount of waste we produce in general. There are many approaches to reducing waste. And from a materials science perspective, we would like to make products out of long-lasting, durable materials that can be repurposed or reused at the end of a product's lifetime.
Is sodium lauryl sulfate toxic?
You're probably asking this because you've seen this chemical listed on your shampoo or toothpaste, and at the levels in those products. No, it is not toxic. This molecule is a surfactant, very similar to many soaps. And like most soaps, if you get them in your eyes, it hurts. The chemical is an irritant, but it does not cause cancer, like you might have heard.
How is a condensation polymerization reaction different?
Addition polymerization reactions do not involve the loss of any atoms from the monomer. But condensation polymerization reactions do. The molecule that is lost is almost always water.
What is a polydentate?
A ligand is described as polydentate if it can bind to a central atom multiple times.
What is thermite?
Thermite is a mixture of a metal powder and a metal oxide that is capable of causing a very strong exothermic reaction. Different metals can be used, but the most common mixture is iron oxide, Fe2O3, and aluminum, Al, powder. The mixture is stable at room temperature, but when it is ignited, it burns in an incredibly exothermic reaction, releasing a lot of heat.
What is a chemical indicator?
As we mentioned, for a titration to be successful there must be some indication of when it has finished. Chemical indicators are a common way of determining whether a titration is complete. In acid-base titrations, chemical indicators are typically small molecules whose colors change depending on the pH of the solution, or, in other words, on their protonation state. In other cases, the indicator may change color based on whether it is coordinated to another species in a solution. It is also possible to use a device like a pH-sensitive electrode to determine when the titration has ended. This doesn't rely on you, or another person, being able to notice a visible change in the color of the solution. Such a device can be more accurate, since it doesn't rely on a qualitative interpretation of a color change.
Why did Otto Paul Hermann Diels and Kurt Alder, both Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their discovery and development of the diene synthesis. Diels and Alder won the prize for the developing chemical reactions that are broadly relevant in organic synthesis. And they even have a reaction named after them called the Diels-Alder reaction. Dienes are complexes containing a pair of conjugated carbon-carbon double bonds, which can react to form a cyclic product in a wide variety of cases. Further research into this class of reactions has found a tremendous number of applications throughout organic chemistry.
What is a spin?
A type of angular momentum possessed by electrons and some other particles.
Why did Arne Wilhelm Tiselius, Sweden, win the Nobel Prize for Chemistry?
For his research on electrophoresis and adsorption analysis, especially for his discoveries concerning the complex nature of the serum proteins.
What is the zeroth law of thermodynamics?
The zeroth law of thermodynamics states that any two systems, call them A and B, that are each in thermal equilibrium with a third system, call it C, must be in thermal equilibrium with each other. Thermal equilibrium implies that the systems must have the same temperature, and therefore systems A and B must have the same temperature. This might seem totally obvious, but it is what puts our use of thermometers to compare the temperatures of different objects on a sound footing. If object C is our thermometer, we can use it to compare the temperatures of other objects.
What's the difference between acetaminophen and ibuprofen?
While the structure of acetaminophen and ibuprofen are very different, the mode of action is similar. Both of these painkillers interfere with the COX family of enzymes we just talked about. Ibuprofen interacts more broadly with members of this family of enzymes, which ends up making it a good painkiller as well as a good anti-inflammatory medication. Acetaminophen binds primarily to one of the members of this family, COX-2, so it's basically just a painkiller.
What metals are naturally present in biological systems?
Sodium, magnesium, vanadium, chromium, manganese, iron, copper, nickel, cobalt, zinc, molybdenum, and tungsten are all naturally present in varying quantities in biological systems.
What is precision?
The extent to which a measurement is repeatable. Note that this is distinct from accuracy.
Why did Hermann Emil Fischer, Germany, win the Nobel Prize for Chemistry?
For his work on sugar and purine synthesase. Fischer showed that various molecules from plants and animals, which were initially not believed to be related, were in fact structurally similar. He went on to show that various sugars could be made in the lab from simple chemicals like urea, with the ability to make sugar molecules. He proceeded to establish the three-dimensional structure of every known sugar.
Why did Alan J. Heeger, United States, Alan G. McDermott, United States/New Zealand, and Hideki Shirakawa, Japan, win the Nobel Prize for Chemistry?
For their discovery and development of conductive polymers. This prize was awarded for the discovery of plastics/polymers that can under certain circumstances, be made conductive. This was quite a surprising result, since nobody ever expected plastics to be conductive materials. These plastics/polymers consist of chains of conjugated carbon-carbon double bonds. In other words, carbon-carbon double bonds that alternate with carbon-carbon single bonds. These polymers were also doped, which means that electrons were either removed or added artificially by oxidation or reduction.
How does your liver process alcohol?
The liver contains an enzyme called alcohol dehydrogenase, which is responsible for metabolizing ethanol. Alcohol dehydrogenase converts the ethanol to another molecule called acetaldehyde, which is then excreted from the body. A healthy liver can process about half an ounce of pure ethanol each hour, which equates to roughly 1 beer, 1 glass of wine, or an ounce of liquor each hour.
Why did Robert Burns Woodward, United States, win the Nobel Prize for Chemistry?
For his outstanding achievements in the art of organic synthesis. Woodward made tremendous research achievements in a broad range of areas in the field of organic synthesis. He established the structures of aureomycin and terramycin, which are antibiotics, and made possible new synthetic work in this area. He also synthesized quinine, which was considered a great challenge and was used to fight malaria, and later synthesized cholesterol and cortisone. The list of synthetic achievements goes on and on. And he truly ranks among the most successful synthetic chemists ever to have graced the field. In addition to these synthetic achievements, Woodward also established the structures of a large number of important compounds.
Why did Richard Adolf Zsigmondy, Germany/Hungary, win the Nobel Prize for Chemistry?
For his demonstration of the heterogeneous nature of colloid solutions and for the methods he used. Although the Nobel Committee didn't mention it by name, the methods he used refers to Zsigmondy's invention of the ultramicroscope, which allowed a visible light microscope to see objects that are smaller than the wavelength of light. Zsigmondy accomplished this, literally, physically impossible task by looking at the light that's scattered off of a sample, and not the light that it reflects. Using this new tool, he showed that the red color in so-called cranberry glass was due to small 4 nanometers, particles of gold, which was of interest to his employer at the time, shot glass.
What is the Big Bang Theory?
The Big Bang Theory is a model that attempts to explain how the universe was formed. This theory suggests that the universe as we know it came into existence a little less than 14 billion years ago, and that everything started from a very dense, hot state from which the universe as we know it began to expand. This theory is based on, and is consistent with, all of the current observations we have surrounding the known universe, such as the fact that it is expanding, or that there exists a large abundance of light elements in the universe. The one thing left unexplained by this theory, though, which you may likely be wondering about, is how that initial state came to be in the first place.
What is the Maillard reaction?
The Maillard reaction is technically non-enzymatic browning, which basically includes any kind of browning that happens when you're cooking, but excludes what happens to cut apples you leave out on the counter. At the chemical level, it's a reaction between an amino acid and a sugar in the presence of heat. A huge number of chemicals are formed in these processes, so you can't really pin down the Maillard reaction to a single set of chemical steps. These processes are responsible for the browning of meat, the malting of barley for beer, the roasting of coffee, and the browning of the crust of bread.
What elements are metals?
Metals are elements that easily conduct electricity. There are a number of sets of metals in the periodic table. Instead of just listing the metallic elements, let's take a look at those sets one at a time in the next few questions.
What are some industrial processes that make use of catalysts?
The chemical industry uses catalysts in a staggering array of chemical reactions that make products that we all use every day. The production of ammonia, NH3, from nitrogen, N2, and hydrogen, H2. Known as the Haber-Bosch process, uses iron or ruthenium catalysts. This reaction is used to generate about 500 million tons of fertilizer per year. Most of the world's plastic is made by one form of catalysis or another. And the refining of crude oil into gasoline and other fuels is also possible because of catalysts. Catalysts are also used in food processing and production. Margarine is made by reacting fats with hydrogen gas in the presence of a nickel catalyst.
What is paramagnetic?
A molecule with no net spin. A material that is only attracted in the presence of an external magnetic field.
How do fireworks work?
Fireworks, those that explode in the sky. Technically called pyrotechnic stars or aerial shells, have only a few essential components. Once the shell gets up in the air, the main event is fueled by aluminum metal or sometimes a mix of aluminum and magnesium metal. By themselves, these elements don't burn quickly enough in the atmosphere, and the flames they produce are just boring white. So this fuel component is mixed with another chemical that helps the aluminum burn. Technically oxidize faster. Different oxidizing compounds make different colored flames when they react. Purple, NO3, blue, CSNO3, green, BaCl2, yellow, NaNO3, or red, SrCO3. There are lots of other components of modern fireworks, like gunpowder, to help disperse these chemicals to make big shapes. But all of the chemistry is based on these simple reactions.
Are all polymer chains the same size?
No. Let's stick with the macaroni metaphor to understand this. Imagine you're stringing noodles together to make a macaroni necklace. You can put as many noodles on a single string as you want. If you have 2 strings, you can put an equal number of noodles on each string or make one longer than another. Again, the macaroni noodles are monomers, which form polymers when we string them together.
How does my ADHD medication work?
Ritalin, R, methylphenidate, is probably the most common drug for the treatment of ADHD. Attention deficit hyperactivity disorder. Ritalin, R, is a stimulant, increasing the levels of dopamine in your brain. Your brain normally releases dopamine to communicate feelings of pleasure and to increase the rate at which your neurons fire, which is supposed to help you focus.
What is the first law of thermodynamics?
The first law of thermodynamics is a statement of the conservation of energy, which tells us that energy can be transferred from one form to another but never created or destroyed.
What makes my cooking pans non-stick?
Heat coating that is placed on cookware is usually polytetrafluoroethylene. PTFE, marketed as Teflon, R, by DuPont, R. The strength of the CF bond, and its reluctance to interact with just about anything else, makes Teflon, R, very heat resistant and slippery stuff. Aside from coating cookware, it's used to make gears and bearings. And it's a key component of Gore-Tex, the material your waterproof jacket is made of.
What are some examples of naturally occurring molecules that affect our biochemistry?
Ascorbic acid, also known as vitamin C, plays an important role in keeping us healthy. It was isolated for the first time in 1932 from citrus fruits, oranges, lemons, limes, grapefruits, and can be synthesized naturally from D-glucose via two distinct biological pathways. The hydroxyl groups allow it to be soluble in water, i.e., in biologically relevant environments, and it is used as a coenzyme in the synthesis of collagen. Benzaldehyde is found in almonds, cherries, apricots, and peach pits. It is often used as an artificial oil of almond. Perhaps not surprisingly, in making perfumes, dyes, and food flavorings. Researchers are also continuing to look into its utility as a pesticide and anti-cancer agent. Benzaldehyde can be readily synthesized in the laboratory using toluene as a precursor. We all know about caffeine. For coffee drinkers, this is probably one of our favorite chemicals. In its pure form, caffeine is just another white crystalline powder. Though most people have probably never seen it that way. It's more commonly found in the cocoa plant, coffee beans, and tea leaves, where people have been consuming it for thousands of years. Historically, people have consumed caffeine to increase their heart rate, body temperature, mental alertness, and attention span. Today, people still use caffeine for most of the same reasons. Caffeine can be extracted using chemical solvents from sources like tea leaves and coffee beans to be used in other caffeinated products like soft drinks. Not to scare you, but it's worth mentioning that caffeine is a potentially addictive substance that stimulates the central nervous system, and if you consume too much at a given time, you may suffer from headaches, irritation, and insomnia. Calanolide A comes from a tree found in the rainforests of Malaysia. It was originally tested as an anti-cancer agent, but was found to be unsuccessful in this regard. However, calanolide A has been found to be very effective in fighting the HIV-1 virus, which causes AIDS. Due to the rarity of this chemical, a synthesis was designed soon after its utility was realized. This drug acts by preventing the transcription of the viral RNA into DNA in a cell, which serves to prevent the HIV virus from replicating. Fortunately, it does this with relatively mild, and temporary, side effects. Dopamine is synthesized in our bodies from an amino acid precursor. It is an important neurotransmitter that balances our feelings of happiness. Imbalances or deficiencies in dopamine production or its regulation have been linked to a number of diseases, including Parkinson's disease, schizophrenia, and Tourette's syndrome. While dopamine was recognized for its role as a neurotransmitter in the 1950s, It took decades of research before its role was more completely understood. The work that led to its connection to the disorders we mentioned, and to an understanding of its exact function, was awarded a Nobel Prize in Physiology or Medicine in the year 2000. An understanding of the role of dopamine in physiology has been extremely important in understanding several neurological diseases. Ethanol is a molecule you are probably familiar with. It's the alcohol found in alcoholic beverages that makes you feel intoxicated, and humans have consumed it for hundreds of years. Additionally, it is useful as a solvent, an antiseptic, a sedative, and a component in perfumes, lacquers, cosmetics, aerosols, antifreeze, and mouthwash. Ethanol can be produced from a raw feedstock, like corn or grain, by fermenting it in the presence of microbes, which can readily digest sugars and produce ethanol as a byproduct. Oxytocin is a hormone produced naturally in females' posterior pituitary glands, which are located at the back of the brain. It is responsible for causing lactation and uterine contractions in pregnant women. Oxytocin is also used to induce labor when a pregnancy does not begin on time naturally. Pyridoxal phosphate is more commonly known as vitamin B6. It helps your nerves and brain to function properly and to maintain the right chemical balances in your body. It is also necessary for the enzymatic reaction that frees up glucose, the sugar monomer, from glycogen, the sugar storage polymer. Vitamin B6 can be obtained from many types of foods including meats, grains, nuts, vegetables, and bananas. Quinine is a molecule that has been used to treat malaria and nighttime leg cramps as well. It was first discovered in South America, in the bark of a type of tree called the cinchona tree, by Spanish explorers, who used it as a medicine. The high demand for quinine eventually led to cinchona trees becoming very hard to find. But thankfully a synthetic method for its production was eventually developed. Succinic acid plays an important role in the Krebs cycle, and can deliver electrons to the electron transport chain. Succinic acid has been found in a very wide range of plant and animal tissues, though its purification challenged chemists for a long time before it was finally successfully purified from tissues. Today succinic acid can be produced readily in the laboratory, and one method even can use corn as a feedstock. In addition to its role in the Krebs cycle, succinic acid has been used as an intermediate in dyes, perfumes, paints, inks, and fibers.